In this video we are going to focus on the tan ratio, and the rule of thumb for tan is tan theta equals opposite over adjacent, and the opposite over adjacent makes sense when you know how to label your triangles. In these questions here we're going to calculate the unknown numerator, and this little green bit here of TOA fits into the acronym of SOT, CUT, TOA. SOT for sine, CUT for cos, and TOA for tan. TOA means tan equals opposite over adjacent, and it tells you which rule you need to use based on the information given to you in the triangle. We are now going to take a look at this question on the left hand side here. We've been given some measurements here. We've got X millimeters, 12 millimeters, and 17 degrees. We have to label the triangle first because normally we're not told which button we have to press. Now I've mentioned that we are doing tan ratio here, but when you don't know, you need to look at the information to figure out whether you're going to press the sine, cos, or tan button on your calculator. So first things first, let's label this triangle. So opposite the right angle and the long side is the hypotenuse. Going from the angle to the opposite side is the opposite. And what's left over that falls next to the angle is the adjacent. So I can see here in this example that I have information for the opposite, the adjacent, but not the hypotenuse, which tells me it's an O and an A, it's a TOA. So TOA, tan equals opposite over adjacent. There is no height featuring, so the rule I use only features a T, an O, and an A. So I need to write the rule. So we start here. So tan theta equals, and it's opposite over adjacent. We always start with the rule. And the next line is our substitution. So it's tan 17 degrees equals, because theta represents the angle, and now I've put the degrees in there. And now I put the opposite measurement, which is X, and the adjacent measurement, which is 12. And again, we're focusing on the unknown numerator, which is why X is sitting on the top here. Now we need to multiply the denominator and rewrite. So I'm going to cross out this denominator, give it to the tan, and I'm now going to rewrite this and put the formula, flipping it back to front. So now it's going to look like X equals 12 times tan 17 degrees. So all I've done here, and I'll go through it again, is crossed out the denominator, given it to the tan, and basically flipped things around. So now I've got X equals 12 times tan 17 degrees, and I pop that into the calculator and it looks like this. 12 times tan button 17 equals, and I get a number that's quite long, and I have to write the whole number out. It's 3.6687,68178, and I'm just going to round to the nearest one decimal, so the nearest decimal there. So I'm going to put a line, which I have, between the first and second decimal and underline the looking number. The looking number is between 5 and 9, which tells me the rounding number must go up by 1. So I have a 3.7, and the units of measurement are millimeters. So now I know that the missing length of the opposite side here is 3.7 millimeters. In the second question here to the right, again, we have information that we need to assess before we go ahead and decide which button we're going to press on the calculator. So we label first. So on the opposite side, the long length opposite the right angle box is the hypotenuse. Going from the angle all the way across to the opposite side is the opposite. And right next to the angle is the adjacent. And the adjacent sits between the right angle and the angle given. So I know I have an adjacent measurement and an unknown for the opposite, and I don't have anything to do with height. So O and A, TOA, tan button, opposite over adjacent. So we write the rule, tan theta equals opposite over adjacent. And then we now do the substitution line. So tan 56 degrees equals, and the opposite measurement, which is the X, the unknown. We're still sticking with the unknown numerator. And the 15 goes as the denominator because that's what the adjacent measurement is. I'm now going to multiply the denominator and rewrite. So I cross out the denominator, give it to the tan, and I'm going to flip it back to front. So x equals 15 times tan 56 degrees. And I punch that in my calculator. I go 15 times tan button, 56 equals, and x equals 22.23841453. And I'm going to round the nearest two decimals here, so I'm going to put a line between the second and the third decimal and underline the looking number. That looking number ranges between 5 to 9, which tells me my rounding number must go up. So x equals 22.24. It's centimetres, so I must put the units of measurement on it. So now I know that my unknown of x measures 22.24 centimetres. In order to achieve the correct answer, you must have your calculator set correctly. You're going to need to make sure it's set to the DEG by pressing the DRG button on your calculator, and that's based on the school calculators. I'm sure that other calculators that you use will have the same function. They may actually be set differently in the wording or the symbols on the calculator, but based on the school ones, you have to have it sitting to DEG, which is shown up on the screen, by pressing the DRG button and going through the process there. Otherwise, if you don't have it set correctly, you will not get the correct answer. We are going to continue with the tan ratio, but now we're going to find the unknown denominator. So everything we did before with regards to the labelling and the rule stays the same. The only change is in the calculation, and that's because the unknown of x does not sit on the numerator anymore, it now sits in the denominator. So we're going to start on the left-hand side here by labelling the triangle. So we're going to label our hypotenuse, our opposite, and our adjacent. First thing we do now is write the rule. Tan theta equals opposite over adjacent. Our second line is our substitution, so tan 46 equals the opposite, which is 25, over the unknown of x. And you can now see that the x is sitting on the bottom here. Now, before we crossed out the denominator, gave it to the tan and flipped it, this is a little bit different. We're going to take this x and swap it with this tan 46. So swap x with tan, and then we're going to rewrite. So x now sits on this side. The 25 stays above as the numerator, but we've now got tan 46 sitting as the denominator. So all we did was swap these two around. And now we read down and we calculate 25 divided by tan button 46 equals, and we get an answer of 24.14221937, and I think I will round this one to one decimal place. So I'm going to put a line between the first and second decimal and underline the looking number. That looking number tells me that I need to stay where I am because this is not between 5 and 9, which makes that one go up. So the answer I'm going to have is 24.1. and it's millimetres, so millimetres goes on the end there. So I'll quickly go through this. Label, write the rule, substitute in. We're going to swap the x and the tan 46 around, calculate, get your answer, round if necessary, and write the final answer with the units. Let's look at the one on the right hand side here. Exactly the same process. Labelling first. Hypotenuse, opposite, and adjacent. First of all, we write the rule. Tan theta equals opposite over adjacent. Second line is our substitution, so tan 7 degrees equals the opposite, which is 18.9, over the adjacent, which is the unknown value of x. We're now going to swap these around and rewrite. So x equals 18.9 divided by tan 7 degrees. And we punch that in our calculator and it looks like this. 18.9 divided by tan button 7 equals, and you get a number of 153.9281475. And this time I'm going to round 2 decimal places. So I put a line between the second and third decimal and underline the looking number. That number is sitting between 5 and 9, which tells me that this rounding number must go up. So I now write the answer of 153.93, and the units of measurement are centimetres.